In this video, we will explain the Singleton design pattern. Singleton is a creational design pattern that ensures a class has only one instance and provides a global access point to that instance. It matters because many backend systems depend on shared resources like loggers, configuration managers, database connection pools, and caches. A helpful way to think about Singleton is as a boundary around object creation. The pattern does not make every shared object good architecture. It simply gives you a controlled mechanism when exactly one coordinating object makes sense. Singleton ensures two important things. First, only one instance of a class exists. Second, the rest of the application has a consistent way to access that instance. Instead of every module creating a new object, object creation is controlled, and all callers are redirected to the same shared instance. In interviews, emphasize both sides. Singleton controls creation and access. If you only mention global access, it sounds like a global variable. The more important part is the class controlling its own life cycle. A simple analogy is a country with one president at a time. Many citizens can interact with the president, but they are not each creating a separate president. In software, many parts of an application can access the same Singleton instance instead of creating duplicate objects. The analogy is intentionally simple, but the software lesson is important. Many callers can refer to one central authority. They do not own that authority, and they do not create duplicate authorities by accident. Without Singleton, multiple parts of the application may create duplicate objects that can waste memory, duplicate expensive resources, and create inconsistent state. With Singleton, one optimized shared service becomes the source of truth. This is useful when the object represents a resource that should be centralized. The biggest engineering reason for Singleton is avoiding duplicated coordination logic. When state must stay consistent across modules, a single owner can be easier to reason about than many independent copies. Common Singleton use cases include loggers, caches, configuration managers, database connection managers, thread pools, and application settings. These resources often need one shared access point because creating many copies can be inefficient or dangerous. These examples share one theme. The object usually manages a resource external to normal business logic. That might be files, network connections, application settings, or operational telemetry. In Python, one way to implement Singleton is by overriding new. The class keeps a class-level variable called instance. When Singleton is called the first time, instance is none, so a new object is created. On later calls, the existing object is returned. That is why obj1 is obj2 evaluates to true. The Python version is concise, but remember that production Python may use decorators, metaclasses, dependency injection, or module-level singletons. The important concept is the same. Repeated access returns one shared object. In Java, Singleton is often implemented with a private constructor, a private static instance field, and a public static getInstance method. The private constructor prevents external code from creating objects directly. The getInstance method becomes the controlled global access point. The Java version is common in interviews because each keyword has a purpose. Private constructor blocks new calls. Static storage belongs to the class getInstance exposes controlled access. Internally, the logic is straightforward. A request asks for the instance. The class checks whether an instance already exists. If yes, it returns the existing one. If no, it creates the object once and stores it for future calls. This is called lazy initialization when creation happens only when first needed. Lazy initialization is useful when the object is expensive to create or may never be used. However, lazy initialization also means the first caller pays the creation cost. Singleton implementations can fail in multi-threaded environments. Imagine thread A and thread B both check whether the instance is null at nearly the same time. Both may see null and both may create an object. Suddenly, the program has two Singleton instances, which breaks the pattern. This race condition is subtle because the code often passes tests in single-threaded scenarios. The bug appears under parallel traffic, exactly where backend systems are hardest to debug. Thread safety solutions include synchronized methods, explicit locks, double-checked locking, and eager initialization. Each approach has trade-offs. Synchronization is safe but may add overhead. Eager initialization is simple but creates the object even if it is never used. Enterprise backend systems must choose carefully. In modern Java, enum singletons and dependency injection containers are also common alternatives. In enterprise applications, Frameworks often manage life cycle better than handwritten global singletons. The advantages of singleton are controlled access, consistent shared state, reduced memory usage, and centralized resource management. When used carefully, it makes sense for resources that naturally should have one application-wide coordination point. The benefits are strongest when the singleton owns infrastructure concerns. Logging, configuration, and connection pools are clearer examples than domain entities like user or order. Singleton also has disadvantages. It can make testing harder because global state is difficult to isolate. It can create tight coupling because many parts of the system depend on one global object. It can also introduce concurrency complexity. Overused singleton can become an anti-pattern. The disadvantages are why many teams are cautious with this pattern. Hidden global state can make tests order-dependent, and order-dependent tests are a common source of flaky CI pipelines. A practical enterprise example is a database connection manager or connection pool. You usually do not want every module creating its own pool independently. A shared manager can control connection limits, reuse existing connections, monitor health, and protect the database from overload. In a real backend service, a connection pool is not just a convenience. It protects the database, controls concurrency, reuses expensive connections, and gives operators one place to observe behavior. In an interview, you can say, Singleton ensures only one instance of a class exists and provides a global access point to it. Use it for shared resources like logging, configuration, cache, or connection managers, but avoid overusing it because it can introduce global state, tight coupling, and testing challenges. A strong interview answer also mentions alternatives. Sometimes dependency injection is better because it provides shared access without hard-coding global state into the class itself. Design patterns are not about memorizing code snippets. They are about recognizing recurring engineering problems and applying the right trade-off. Singleton is useful when one shared instance is truly needed, but it should be used intentionally and with awareness of testing, concurrency, and architecture impact. The main takeaway is judgment. Singleton is neither always good nor always bad. It is a tool for one instance resource management, and good engineers know when the trade-off is appropriate.